Okay, hello, good afternoon.
Good afternoon, sir.
Afternoon, sir.
So nakakuha naman mo sa copy sa syllabus, no? Naka-download na mo copy sa syllabus. Ikan sa Canvas. Okay, so that's good. So makita na ninyo ang akong i-present. Notes. Okay, so sa atong subject sa Foundation Analysis and Design, doon na tayo lecture materials, no? So I will have this printed and softbound. Hopefully it will be finished within this week, no? Maybe Friday. So just prepare for maybe 200 pesos, no? Sa photocopy of softbound. So posible siguro nga magkita lang ta dito sa Civil Engineering Department by Friday if it is already completed, no, or finished. Ito na ito i-distribute ang copy sa atong kanyang lecture materials. So is that all right with you?
Yes, sir.
Kaya? O sige. So karon magkuha na lang ta, mag-discuss ta sa primero nga part niini, no, sa atong subject. So ang atong subject, Foundation Analysis and Retaining Wall Design. Actually kanang retaining wall is still part of the broader nga subject sa foundation design, no. Ay buong lang kung anong explicitly specify pag siya sa atong course title. But mao na siya ang original gyud, no, nga titles nining course, Foundation Analysis and Design. So in this subject, we will be learning how to design different types of concrete foundations. So mao na importante ang definition of terms nato dire unsa man ang gitawag nato foundation, no? So foundation is defined as that part of the structure which is usually placed below the surface of the ground and which transmit the load to the underlying soil or rock. So ang definition nato, no, sa foundation ni specify as ang iyang location. So it is usually placed below the surface of the ground. So we cannot see it, no? Na siya sa below ground. Ang iyang purpose is to transmit the load to the underlying soil or rock. So ang superstructure nga load which can compose of dead load, live load, and mga wind load o seismic load ultimately has to be transmitted to the ground, no? So ang atong ground can be made up of soil with different characteristics or pwede sa rock, no? So there are two essential requirements in the design of the foundation. So first, total settlement of the structure shall be limited. Then second, differential settlement shall be eliminated as nearly as possible. So duha ka requirement to limit a total settlement and to eliminate as nearly as possible differential settlement. So by total settlement, we mean that the entire structure will settle more or less at the same magnitude, no? So mounlod dungan ang tibuok gyud nga building, no? Sa differential settlement, only one portion of the building will settle while the other does not, no? So, between ining duha, total settlement, differential settlement, ang differential settlement mo ay mas problematic, no? Because it will cause tilting sa atong structure. So kanang famous kayo nga Leaning Tower of Pisa, so ni takilid ang tower, it leans, no? So kana siya, tungod na siya sa differential settlement. Dili even, no? Differential or uneven settlement. So ang differential settlement will cause na siya, mo result na siya, no, sa ining stresses ngadto sa superstructure elements. So as much as possible, it should be eliminated. So doon na tayo duha ka kining general solution na to, no, on how to kining fulfill the essential requirement. So first, we transmit the load to a soil stratum with sufficient strength, and second, to spread the load over a larger area of the stratum to minimize the bearing pressure. So pwedeng palitan na kay differential layer, and at 1.5 meter depth, 100 kPa ang bearing capacity, ang at 2 meter depth mosaka siya to 200 kPa. So mas maayo nga atong footing atong we place it at 2 meter depth, no? So ingon na, no? So we transmit the load to a soil stratum of sufficient strength. Another solution will be to spread the load over a large area. So we increase the footing size. So suppose you have a low bearing capacity, by increasing the footing size, then the bearing pressure will be decreased also, no? So mo ni siya ang duha ka kuang gyud general nga approach, no? Transmit na to ngadto sa sufficient strength, or you increase the footing size to spread the load over a large area. So there are classification of foundations. So we have 1, 2, and 3. First one is shallow foundation. Second is the deep foundation. Then third is the retaining structures. So in the figure below, I have shown here a sample of kining shallow foundation. Example of that is the spread footing. So it is called spread footing because its purpose is to spread the load to the soil, no? So other name for that, you have the isolated footing, or if it is a square, we call it a square footing, no? Then in figure B, you have the pile foundation, which is an example of a deep foundation. So the pile will transmit the load to the soil by two components. We have here the friction between the pile and the surrounding ground or soil. So that is called skin friction. And at the tip of the pile, you have here the point bearing reaction. So sa mga yuta nga humog kayo, then even at significant depths already, so the load will be transmitted primarily by friction, no, at the surface of the pile. So that is called a floating pile. Whereas if the pile touches the bedrock, no, so you have a large point bearing resistance, that is called a point bearing pile. In figure C, we have here the retaining wall. So the purpose of the retaining wall is to retain soil or other materials, for example, in mga sand, stockpile sa sand or stockpile sa gravel, or other granular nga materials, no? For example, coal. So pwede sa nato gamitan og retaining wall. Okay? So these are, no, in these subjects we will be studying shallow foundation and retaining structures, no? So the design of the foundation falls in the scope sa advanced foundation design, no, which is usually discussed in the graduate program sa civil engineering, no? Okay, so mo na siya duha ray atong i-treat diri, no? So first you have the shallow foundation, and third you have the retaining structures. We do not deal here with the design of piles. Now, for the design of the foundation, there are general considerations. So first, we need to determine the building profile or the building purpose, the soil profile, and the construction methods and cost. So So of course, when you design foundation, you have to know what the purpose, no, for which the building is built, no, and then you have to determine the soil profile. So the purpose of this will be to determine the strength of the soil, no, its bearing capacity, the possible magnitude of settlements, and in some cases, the liquefaction potential during earthquake. No? So that knowing the soil profile, you can design the appropriate foundation type. Then in design foundation, we also need to consider the construction methods. So for example, when we construct foundation at the urban areas, no, where there are already existing buildings, then we need to excavate, no, for the basement. So we need to design the foundation properly, no, including the excavation protection. And if water is encountered, then we have to factor it in, no, in the design of the foundation. Then second, we have to determine the client or owner's needs. So for example, if the client, due to financial constraints, no, siya planong 10-story ang tayo tukuron nga building, but for now, ang iyang makaya 5-story ra, no, then there is a plan for future expansion. So we have already to consider that, no? We have to design the foundation not only for to carry 5 floors, but for the 10 floors future expansion, no? Then third, we have to make design with a margin of safety. So for example, the allowable bearing capacity is obtained by dividing the ultimate bearing capacity by a factor of safety, which is usually from, some will use 2, 2.5, 3, 4. So depending on the importance of the building, no, which is to be supported by the foundation. Okay, so also we have what we call specific considerations in the design of the foundation. So first, the depth must be adequate to avoid lateral squeezing of the material. So if you place the foundation at a shallow depth, there is a possibility that the soil underneath the footing will be laterally squeezed, no? So that will result into settlement. So kinahanglan sufficient ang depth na to avoid lateral squeezing. So you might have experienced this, for example, in the beach, no, when you walk over sand, no, when you step on the sand will be laterally squeezed out, no, and your footing or your foot will sink, no, into the sand. So sand has a very weak bearing capacity when it is unconfined, but very strong bearing capacity when it is confined. So second, the minimum depth must be below seasonal volume changes and plant growth. So in the Philippines, we don't have much problems seasonal volume changes, but in other countries, no, where they have winter, so the top layer of the soil will be subject to changes in extreme changes in temperature, no, so it will expand and contract, it will move, no, together with the thermal variation. So ang imong footing should be placed below, no, niya na nga layer nga magsigig change ang iyong volume, because that will cause the structure to move, no, and we don't want the structure to keep on moving, no, together with the soil. Then also plant growth, no, so if there is a tree adjacent to the structure, it is good to place the footing below the roots, no. If we cannot uproot the tree because it is not allowed, no, by certain government restriction, then we have to place the footing below the root, no, of the tree, because otherwise the roots might penetrate underneath the footing, no, where there are cracks and there is water, no, so it might break the footing. Then third, foundation scheme may have to consider expansive soil condition. So there are soil types which are very strong when they are dry, no, when they are, but they become very weak or unstable when they absorb moisture, no. perimeter, or we can design the foundation type, for example, a waffle foundation, to control the direction of expansion. No? Or sometimes, but more costly, is to make the foundation heavy to counteract the uplift, no, due to the expansion of the soil. Then fourth, system must be safe against corrosion or deterioration due to harmful agent in the soil. So this is especially a concern if we are constructing on landfills, no? So landfills na i-dump diha nga lain-lain nga mga materials, mga chemicals which can be harmful to the soil or to the footing, no? Or sa foundation near outfalls or sewers. So kinahanglan sad nga ato ng bantayan, no? Then fifth is regards the statical stability, no? So the foundation must be safe against overturning, sliding, and uplift. And of course, the materials, no? So in our case, you have reinforced concrete, which is composed of concrete and steel, no? So your concrete should be of adequate strength so that it can support the compressive stress, amount of tensile stress. If not, then we have to provide steel reinforcement to carry the tension, no? Then six, the foundation should be adequate to sustain later changes in site or construction geometry. So the example that I cited a while ago, if the owner plans to build a 10-story structure, but for now the budget allows only for 5-story, then we should design the foundation already for the 10 floors, no? So that it will be able to accommodate additional floors in the future, no? Otherwise, it's very difficult to retrofit sa mga foundation, very costly, no, and very difficult. Then 7, foundation should be buildable with available construction personnel and equipment. So in my experience, there are some projects which the initial foundation design was changed because to implement the foundation on site, encounter several problems. Like for example, on densely populated area, no, commercial areas, it is discouraged to use driven piles, no, using diesel hammers, because those pile driving method creates a lot of sound, no, smoke, then also vibrations, no, which could damage adjacent structures. So kung maghimo ka kuan diha, no, then you don't recommend kining mga driven piles. So you should look for other option. So another option could be the use of board piles, no. The number 8, foundation should meet local environmental standards, so especially when the excavation is quite deep and it will intercept the water table. So care must be taken so as not to contaminate the water table. Yung mga excess materials, no, kinahanglan nga tanahon karon di siya malabay nga to sa public sewer, no. Okay, so next we have the steps in the design of the foundation. So first, we locate the site and position the load. So from the initial nga mga layout, no, sa building relative to the lot or the site, we can determine asa dapita diha ang bugat nga load, no, asa tunggaan, no, asa ang tower nga portion, asa sa dang podium nga portion, no. Then second, we conduct site inspection, which can be supplemented with previous data. So if there are available data, no, sa adjacent to mga structure, then it's better, no, because it will give us a more comprehensive information, no, regards the soil condition on site. So site inspection will disclose, no, on site situation sa kining surface, no, siya mga vegetation, kita sa nato ang yung slope, no, dool ba siya sa kuan kanang mga cliff, no. So it's important to conduct site inspection. Then third, we do field exploration program. So this is the soil investigation. So ang tuyo na is to determine the property of the soil, no, on which the building is to be constructed. So ang buhaton doon ay mga equipment, no, nga mo drill, no, sa site, and it will record the number of blows per, say for example, per inch of penetration, no. Then the equipment will also retrieve soil samples at different layers. Then those samples will be brought to the laboratory for analysis, no, sa iyang property. Sa sieve analysis, pag-determine sa iyang plastic limit, liquid limit, no, ang iyang particle size distribution, ang cohesion sa soil, no, ang angle of internal friction. And from this, no, we apply katong mga empirical formulas, no, so that will be translated to the ultimate soil bearing capacity, no. There are several equations for determining the ultimate soil bearing capacity, and then that one is divided by a factor of safety or a recommended, no, value which can be used in the design. So that's the fourth, no, determine soil design parameters. Then fifth step will be to conduct load test and capacity verification. So this is warranted especially if we have a major structure, no. So for example, after step 3 and 4, you might have already an initial length of pile, no. So a certain pile diameter, then a given pile length. Pero kinahanglan nga imo na siyang testingan, no. So magpakaskag ining test pile sa site. Then you apply load test, no? So load test can be dynamic, it can be static nga testing. So ang tuyo na is to verify, no, the actual capacity of the pile. There is a load, vertical load applied to the pile, then the settlement of the pile is being measured. So niana, no, ma-determine to kung atong ining computed ng pile length, yung capacity sufficient ba o dili, no? Kung suprasad kayo, then we can decrease the pile length. If it's insufficient, then we should adjust, no, by increasing the pile length. So before we must produce the piles. So that is for load testing and capacity verification. Then after that, we have the structural analysis and design of foundation. So that's the final step, no? So usually, kining locate site and position the load, it is the structural engineer which will determine, no, the location of the boreholes. Site inspection to be conducted probably jointly by the structural engineer and the geotechnical engineer. Step 3 and 4 is done by geotechnical engineer, no. Then fifth, maybe a joint effort of contractor, no, mga structural and geotechnical consultant. Then number 6 will be the work of the structural design consultant, no. By the way, if you have some comments or questions, feel free to interrupt, no. Sometimes we will schedule a face-to-face class, no, but not yet this week. Probably next week we'll schedule one, no, so that I can also meet everyone face-to-face. Pero sa pagkaroon ko ana sa tanin online, no. Okay, in table 1, we have here the foundation types and typical usage. So in the first column, you have there the foundation types. Second column, the use, no. Say gamit yan ang foundation type. Then third column, where those foundation types are applicable, no. So for spread footing, wall footing, combined footing, they're applicable when bearing capacity of the upper strata is adequate. So when we say upper strata, maybe from 1 meter to 3 meters of soil, no, is of adequate bearing capacity. So we can use the shallow foundation, no, which can be spread, wall footing, or combined footing. So spread footing used to support a single column, Wall footing used to support reinforced concrete walls or load-bearing walls. Then combined footing used to support more than one columns, no? So usually 2 to 4 or maybe even more, no? Number of columns when the space is limited. Then when the soil bearing capacity is less than for spread footing, so we can use a mat foundation which will support several columns or even all the columns of the building, no? Then if still this is insufficient, then we use either floating pile or bearing pile. So bearing pile, if the pile reaches the bedrock, so you have point bearing transfer, no? Floating pile, if the bedrock is quite deep, so we don't reach it, no? So the load is transmitted by friction, no, at the surface of the pile. So these are called friction pile or floating piles. Then for heavier loads, for larger column loads, like for example, the third bridge, or kanang mga bridges na to, there are very huge pillars that support the bridge. So we have the drilled piers or caissons. But they have the same principle as piles, can be floating or point bearing or a combination of the two. Then 8, you have the retaining wall or abutments in case of bridges, So the use is for permanent material retention and applicable soil conditions in the soil type, but for the backfill, at the back of the retaining wall, it should be of controlled characteristic, Then 9, you have the sheeting structures, which can be sheet piles, which are made of either wood, steel, or concrete, So sheet piles or sheeting structures are used for temporary or sometimes permanent, for excavation. So kung magkaotag kuan foundation sa high-rise nga building na atay duha ka basement, then to protect or to prevent collapse of the walls of the excavation, we provide sheet piles. So applicable soil condition is when we need to retain any soil or water. So we use sheeting structures. Okay, so I think we still have 10 minutes or 9 minutes more. So let's proceed with this part here, So we have here the common problems encountered in foundation. So we have, I think I have listed here 8, 8 common problems encountered in foundation. So first we have the erosion problems. So for structure adjacent to flowing water. So I think you were not yet born by that time, but the Mananga Bridge, in Tabunok, collapsed, due to scouring of the riverbed, and it exposed the timber piles, which deteriorated and resulted into the collapse of the bridge, So those are erosion problems. So factors to determine scour depth is the depth prior to erosion to bedrock, subsequent redeposition of sediments. So as during flood stages, you have a high velocity, so the soil will be scoured, But as the flow subsides, so mahinay na ang iyang velocity, the water will deposit the soil that it carries, So that is what we call redeposition. So we need also to consider stream velocity. If you put a pillar, in between or at the middle portion, for example, where river, then it will cause obstruction, sa imong river channel, and that could increase, or accelerate the flow, of the water, resulting into faster scouring, So solution to erosion problem, we have to use spread footing at sufficient depth, or if erosion is really quite often, So we just use piles, Normally piles are required to support foundation. Then second Common problem is corrosion problems. So all sanitary landfill, shoreline, or outfall sewer and industrial plants, backwater areas, no, which contains standing water or dead vegetation. So one solution to this to counteract corrosion problem is the use of concrete resistance to corrosion. So if sulfate are present, we can use sulfate resistant concrete, and we can also use explore the possible use of timber piles, no, for soils with pH greater than 9.5 or pH less than 4.0. So pwede siya ang timber piles, no. So most of the old buildings, no, located in downtown Cebu, ng mga multi-story na, no, they are supported on timber piles. But nowadays, timber piles are not so common, no. So naman mangita o kanang dagkod ng mga kahoy. So ang common karon is the reinforced concrete pile, which is pre-stressed, no. And we also have at times kini mga steel piles. Then third, you have the water fluctuation problem. So lower water table increases effective pressure, resulting to additional settlements. And raised water table can create instability from floating the structure and reducing effective pressure, and may create wet basement if basement walls are not watertight. So here in, for example, sa Ayala Business Park, there are some buildings there where they have a problem sa kuha, kining mga leak sa ilang basement. So during heavy rains, magkuhansad, no? So lang tubig sa ilang basement, no? Due to leak. Kuhan. So muna ang importante ang design sa basement, no? Nasa yung mga basement nga kuhan. Kining kuwang siya reinforcement, so when it is subject to hydrostatic nga uplift, so the concrete will crack, no? So we have encountered that in some areas here, no? Okay, so fourth, you have foundation on sand deposits. So we'll require consideration of bearing capacity and settlement. So loose deposits must be densified, or another solution will be to place the footing at sufficient depth that the soil beneath the footing is confined. So it is poor practice to place footing on sand deposits where the relative density is less than 60% or maximum dry density is less than 90%. Then we have also foundation on collapsible soil. So there are certain types of soil structure where if it is wet, it becomes weak, no? So it easily collapses and resulting into large settlement. So general recommendations are the following. We can use compaction, or we can apply admixture, lime fly ash or Portland cement, or to prevent moisture, which is often impractical, because it's difficult to really contain, the area. Or another solution would be to the use of piles to transfer the load to a more competent stratum, But again, kining use of piles is very expensive, and should be considered only as a last option. Okay. Then 6, you have foundation on expansive soil. So the soil undergo volume changes upon wetting and drying. These are soil which contains large amount of clay, So to solve this problem, one may alter the soil by addition of a mixture, like for example, lime or cement, or you can do compaction, or the use of waffle type foundation, which controls the direction of the expansion. Or we can also control the water by excavation, then laying a plastic fabric and backfilling. So place the footing at sufficient depth, or leaving an expansion zone, or load the soil to sufficient pressure to balance swell pressure. But again, this is a rather expensive solution because we have to make our footing thick. Now 7 is our foundation on sanitary landfills or garbage dump. So for this one, the soil property is really variable. Even in close proximity, no, ng mga locations. So that sa usa ka location medyo gahi siya, no, magkatunong ka og mga kining solid nga mga garbage, no, but at some other location labay ng garbage mga kining biodegradable, no, so mahumok sila, no, so kuyaw na siya sa uneven or differential settlement. So to address this problem, no, one may undertake the following. So place additional fill to reduce the pressure on the refuse zone. So refuse zone katong layer no nga naa ditong garbage, no. So tangani mo baga nga kuan kining soil nga fill. So ang effective soil pressure nga maabot dito sa refuse zone ma-diminish na siya, no. Or another solution will be to use continuous foundation, that is for lighter structure, or use of piles, no, either treated timber or precast concrete piles. And finally, we have foundation slopes. So of course, we have many of these here. No, I think the other week there was a collapse, no, sa Maria Luisa, still ongoing construction after heavy rain. The slope collapsed, no, landslide. So the structure may be supported on stilts, which must preferably be tied. So using tie beams, no. Leveling the site may require high retaining structure, which must be provided with adequate drainage. So you can see the solution being implemented if you go around Maria Luisa or Busay, no. So pero importante ni siya, no, so, because there are several incidents of slope failure. So one needs to do a slope stability analysis, no. Naibukid butangan na mo na siya o building, you are putting additional load, no, to the soil. Or if you cut the soil, it is no longer its natural slope and it becomes unstable, no. Okay, so it is already 4:31, so I think we will just end our as for this meeting here. So we'll continue next meeting on the succeeding pages. Okay. So I hope that will be sufficient for now.
Excuse me, sir.
Last minute question.
Sir, can we agree, but what will be our schedule for face-to-face session, sir? Will there be a regular day of the week?
Maybe we meet MWF man, no? So we can do lectures 2 days online, then 1 day face-to-face. So maybe every Friday we do face-to-face. And also the exams will be conducted face-to-face.
Sir, would it be okay though? Because I think the block agrees to have, if I think the whole block is available at this time, would it be okay though if we meet face to face on Wednesday, 10:30 to 11:30 in the morning? Will it be okay for you, sir?
Wednesday?
Yes, sir.
Anong di man sa kaninga time?
Para lang sad convenience, sir, because we have another class sad during near that time kana morning, Wednesday morning. So more na among proposal, sir, para mausa gani among
Wednesday 10:30, no?
Yes,
so,
sir.
But do we have a room?
I think we can find her, sir.
Sige daw, ikuan daw, tabangin daw kung pangitag room niya na. We can ask the chairman, no? Kung nabay ko, 10:30, no? 10:30 to 11:30.
Yes.
So 10:30 to 11:30. So let's try to ask the chairman if there is a room available, no, at this schedule. So if there is, then we can do that, no? 10:30 to
Yes, sir.
11:30. Okay. Sige. So doon na pa ba
Thank you, sir.
lain nga concern? Kanara? Sige. So ayan na
Sir,
to, kuwan.
since you last question, I guess, so far, sir. Since you mentioned exams, sir, you mean finals, like finals na mo, sir?
Not only finals but kuwan, other exams kuwan atong ihatag. Of course, all exams will be announced. Maybe we can have it on Wednesdays, no? Not every week, no? Maybe depending, no, on how much we'll be able to cover.
See? Okay, noted, sir. Thank you, sir.
So okay na ta? Time naman siya, no? Sinapa mo yung klase. So, sige, ayaw mo diya. Basta ang atong lecture materials, I hope that it will be ready by Friday, no? So, okay, so sige, ayaw.
Thank you, sir.
Thank you, sir.